Hello, my name is Wieslaw. In the last video I showed you how to imagine a linear form in algebra. Now we're gonna explore operation on elements of dual space. So we'll see how to easily visualize addition and scalar multiplication in the space of one forms. Let's start with some form alpha. From the previous video we know that we can imagine it as a so-called level set with the direction when color becomes stronger. We have also another form beta, and our goal is to see how to graphically add such forms, because the dual space in which these forms live is a vector space, so the addition should be possible. For simplicity, let's leave only 3 lines for each form, and let's choose some point, and from this point it will be useful to construct some vectors that will help us in our construction. Let's take vector A that is parallel to lines of form beta and crosses exactly 2 lines of form alpha. It will be useful to take another vector B that is parallel to lines of form alpha and crosses exactly 2 lines of form beta. Then we can create a line through the heads of that vectors. We postulate that this line will be the second line of our sum form. We need also a zero line for that form, and it's the line passing through the tail of that vectors, line that is parallel to the upper one. For the value of some form on vector A and B to be 2, we need intermediate line between lines that we've constructed, and this line also should be parallel to others. The form that we've constructed we may call gamma, and we need to convince ourselves that this construction is correct. But this construction is correct if the value of form gamma on any vector is the sum of values of form alpha and beta on that vector. Let's check it out. The value of form gamma on vector A is the sum of value of form alpha on that vector. As we can see from that picture, the vector A crosses exactly 2 lines of form alpha, so the value of form alpha on vector A is equal to 2. And we should add to this the value of form beta on the same vector A. But vector A was chosen to be parallel to the lines of form beta, so that value is equal to 0. And as the result we get 2. But this condition isn't sufficient to know that our construction is correct. We need to examine the value of form gamma on vector B. So this time vector B is parallel to each line of form alpha, so the value alpha of B is equal to 0. And we need to add to this the value of form beta on vector B, but the vector B crosses exactly 2 lines of form beta, and as the result we also get 2. So this construction determines the orientation of form gamma. To reinforce this, I have little riddle for you. So let's leave on the screen only forms beta and gamma and try to construct another form that will be the sum of form beta and gamma. It may be useful to introduce here some coordinate system, and with it try to construct that sum. In the next video I will present the solution for that task. But to have a more complete visualization of dual space, we need also see a scalar multiplication in the space of one forms. Let's come back to the form alpha, and for example, we are looking for form delta that is equal to 3 times form alpha. How can we construct it? We also start with some vector A. This time there is no need that this vector is parallel to some another form beta. For fixing attention, we also assume that the value of form alpha on vector A is equal to 2, and the value of form delta on vector A should be equal to 3 times the value of form alpha on that vector, so it should be 6. So we need exactly 6 lines crossing vector A. So the level set of form delta should be 3 times denser than level set of form alpha. For simplification, let's leave only the lines crossing the vector A, and we see that the form delta is properly chosen. Now we see that the dual space is an ordinary vector space, and we can visualize operations in that space. But what about higher dimensions? We're gonna see how to generalize it for 3D space. In the last video, we've seen that in 3D space, we can visualize one forms as a set of certain parallel planes. We've here one form alpha and some another form beta, and for adding them, we need similar construction as on the plane. We choose some point when these families of planes are intersecting, and from that point we construct a vector A that is parallel to planes of form beta and is crossing exactly 2 planes of form alpha. But in this case this vector is insufficient for our construction. We need another vector which we call A prime, and is also parallel to planes of form beta and crosses exactly 2 planes of form alpha, but the direction of that vector is different. Let's see from another perspective that these vectors are indeed parallel to that plane. And we need last vector which we call B. This time it's parallel to plane of form alpha and crosses exactly 2 planes of form beta. So as the value of form beta on vector B is equal to 2. And the main idea of our construction is that the value of some form gamma on each of that vectors should be also 2. So we need to construct a plane through the heads of that vectors. Let's see it from another view. This blue plane is constructed as the second plane of our form gamma. And we need also a zero plane for that form, and the zero plane should be parallel to the first one. And to finish our construction, we need intermediate plane lying between them, and being also parallel to them. In such a way we've constructed the sum of form alpha and beta. Let's see this operation of addition from different perspectives. And the scalar multiplication in 3D space is also very similar to visualize to what we've seen on the plane. I hope this video was helpful for visualization of simple dual spaces. If you have some questions, please comment below and don't forget to like and subscribe. See you next time.